The next topic in streams internals deals with the execution phase. And this basically shows how stateless and stateful intermediate operations and both runtime and short-circuiting terminal operations are actually run by the framework. Remember, before we talked about construction, where we showed how things were built. Now we're going to talk about how things are run. And this all works by something called an execution plan. That's what this is, it's an execution plan. And remember, this is all going to start when the terminal operation is reached. So when the terminal operation is reached during runtime, where the Java bytecode, if you're on a JVM, is building up that linked list of stream stages or nodes. When it hits the terminal operation, at that point we have everything we need to do, or Streams Framework has everything it needs to do to go ahead and start execution. Now, where does this plan come from? This plan is based on properties of the source and aggregate operation. Surprise, surprise. That's, of course, what you'd expect. That's why they went to the trouble of building up that internal data structure that keeps track of whether the things are sorted or ordered or sized or distinct and so on. Intermediate operations in this model, this execution plan, are divided up into two categories. You're already aware of these categories, but now you'll see very deliberately why they're so important to distinguish. The first category is operations that are stateless. So these would be things like filter, map, flat map. Let's see, some other ones would be map multi that we've talked about, and so on and so forth. So if you have a pipeline would be this whole thing on the right, that only has stateless operations, then we can run the stream in a single pass. Just call each of the operations in sequence, even if it's in parallel, in which case everything will run in parallel, or many of them will run in parallel. So everything can run in a single pass, which is faster. Conversely, if you have stateful operations like sorted, distinct, limit, drop while, take while, and so on, those have to be split up into multiple sections and run in multiple passes. And that's because, as we talked about before, everything needs to be accumulated. If you have a stateful operation, you have to accumulate everything before you can go on to the next phase. Whereas with the stateless operations, you can do it in a single pass. So once again, just to give you a better intuition about why stateless operations are cheaper than stateful operations when we're talking about stream intermediate operations, it's because of the fact you can do it in a single pass as opposed to multiple passes, which means there's less need for buffering and all this other stuff that you'd need to do if you did it in multiple passes. So this is a good example of how knowing how streams work under the hood helps you make a better choice about what operations to use. Terminal operations are also divided up into two categories. And those categories are run-to-completion operations. Those would be things like reduce, collect, for each, and so on. And these terminal operations process the data in bulk using the split iterator for each remaining operation or method. So for each remaining, if you recall, does everything that split iterator controls in one fell swoop. So it starts and it keeps running until it either finishes or there's an exception. So that's how run-to-completion terminal operations are handled. Again, reduce, collect, for each. There are also short-circuiting operations like any match, first match, and so on. And the idea of those is that as soon as they fail to meet their predicate, they bail out. So if you're doing any match, as soon as you find a match, you bail out. For find first, as soon as you find one, you bail out. For match, none match, if you find something that matches, then you bail out, and so on and so forth. So these terminal operations, because they may need to bail out as soon as they find something that doesn't match what they're looking for, or does match what they're looking for, they advance one element at a time using try advance. So run-to-completion stuff uses for each remaining. Short-circuiting uses try advance because they have to be more fine-grained in how they want to handle the bailing out because of the short-circuiting semantics. So that gives you a quick overview of how the execution plan is picked. Obviously, there's lots of implementation details. If you're really curious, you can go look at the code. It's not very well documented, and it's written in a somewhat cryptic way for my aesthetic. So it's not the easiest thing to understand, but it's out there. And you could probably, if you were really curious at how it worked and why it did what it did, you could probably cut and paste it into ChatGPT and get it to explain and summarize what the code does. That would actually be kind of a fun exercise to see if it could figure it out. So that's the end of the discussion of execution plans with stream internals.